So now we'd like to look at some examples of working a force problem in 2 dimensions. So the key idea on doing these is that we want to first draw a free body diagram, then after that we use the second law of motion and set the sum of the forces in the x direction to be equal to the mass times acceleration in the x direction, and the sum of the forces in the y direction are equal to the mass times acceleration in the y direction. So let's check this problem out. So we've got a block and it is on a surface, and the coefficient of friction between the block and the surface is 0.6. So the hand is pushing on the block 1 and the block moves to the right with an acceleration of magnitude of 5 meters per second squared. So what's the force that the hand exerts on the block? Well, our step 1 here is to draw our free body diagram. So let's do that. So we've got our weight force, so weight 1e. We've got our normal force pointing up, so this is N1s. To the right, the guy is pushing on the block, so to the right, the normal force, because it's a pushing force, so it's normal 1h. And then the friction force. So in this case, the block is sliding to the right, so that means that the friction force is pointing to the left. So we have our free body diagram. I think we've identified all the forces here. So now we want to be able to solve this. So that means that our next step is to use the second law of motion to set the sums of the forces equal to the mass times acceleration. So what do we know here? So the thing is, the hard part is finding the value of the normal force by the hand on the block. So we know the weight force, and finding the normal force that's due to the surface, that is pretty straightforward. So that should be the first step, because we know all of the forces in the y direction. And then in the x direction, well, we need to know the normal force by the surface before we can find the friction force. So that tells us that we need to do the y direction first. So that means that the sum of the forces in the y direction is equal to the mass times acceleration in the y direction. And, well, the acceleration in the y direction is just 0, so since the block is on the surface, so it's on the shelf here, and so that means the sum of the forces in the y direction is equal to 0. I'll say newtons here. So what other forces do we know? Well, we've got our weight force. So weight 1e, so our weight force is equal to minus mg. So am I on the page here? I am. So this is going to be negative 3 kilograms times 10, so it's negative 30 newtons. So, and then the normal force by the surface, we don't quite know that yet, but the mass times acceleration in the y direction is 0 newtons. So minus 30 plus what gives us 0 newtons, so this has to be 30 newtons. So yes, we want to be a little careful here, because the normal force by the surface is not always equal to the weight force. So we can imagine a problem where I'm pushing down on the block, or we have a rope pulling up on the block, and in that situation the normal force and the weight force will not be equal to each other. So I always want to make sure that this is true, but in this case this is a pretty simple problem. So yeah, so the weight force and normal force are equal in magnitude. Okay, so now we want to look at the y direction. So in the x direction. So the sum of the forces in the x direction is equal to the mass times the acceleration in the x direction. And, well, in this situation, the acceleration is 5 meters per second squared. So that is going to be the mass, so 3 kilograms times 5 meters per second squared. So that means the sum of the forces in the x direction have to be 15 newtons. Okay, so next we want to find the values of the forces in the x direction. So what do we have? We go back to our free body diagram, and we have the friction force, and we have the normal force. So the normal force is the one we're trying to find. So what is the friction force? So the friction 1s force, this is going to be equal to mu k times normal 1s. So mu of k, the kinetic coefficient of friction, is 0.6. The normal force is 30 newtons. So that means friction 1s is 18 newtons. And if we look at our free body diagram, it is pointing to the left. So that means the friction force is negative 18 newtons. Okay. And so now the normal 1h, so we don't know the value of that. That's what we're trying to solve for here. Let me push this up a little. And then the mass times acceleration in the x direction, this is 15 newtons. So how do we solve this? So minus 18 plus something gives us 15 newtons. So we can turn this into equation maybe to make this a little easier. Minus 18 newtons plus normal 1h is equal to 15 newtons. So N1h is 15 plus 18. So this is 33 newtons. Okay. So the strategy was very similar to what we've done before. We first drew the free body diagram. Then we found the forces in the y direction by setting the sum of the forces equal to the mass times acceleration in the y direction. Then we used the normal force that we found in the y direction to find the value of the friction force. And then in the last part we looked in the x direction. We know the friction force. We know the acceleration in the x direction. And so then we solved for the normal force by the hand. So let's check the second problem. So this is the one I think you have to do. So I don't want to overdo it here, but this is a very similar problem. So in this case, we've got a box that is located on the surface of a table. The hand is pushing to the right, and this time we are given the force. So we are told that the force is pushing, the normal force by the hand is pushed to the right by 72 newtons. The friction force we can find using the kinetic coefficient of friction. So we're told it is 0.4. So that means we need the normal force, and finding the normal force shouldn't be too difficult in this situation. We do that by finding the sum of forces in the x direction. So the point is, you're going to do this problem exactly the same as the previous problem. You're going to draw your free body diagram. It's going to have the same four forces pretty much as the problem before. Then the difference is, in this case, you're trying to find the acceleration. That's kind of the final solution here. So you are given the 72 newtons or whatever it is in your problem. You're given the coefficient of friction. So that means you're going to have the net force in the x direction, and then that's going to be equal to the mass times the acceleration in the x direction. So you can solve for that. Okay, so I don't think these should give you too much trouble, but as we move into our class for Wednesday, we're going to start to look at static friction. We're going to start looking at some a little more complicated versions of this kind of problem, but we want to get down the basics, so let's do two of these problems where it should be pretty straightforward. All right, I think this is a good place to stop this class, so good luck with your problems and take care of yourselves.